This problem is based on heating effect of current. When current passes through a wire, heat is produced. The heat produced per unit time, the heat produced per unit time is given by V squared by R, where V is the potential difference and R is the resistance of the wire. The resistance of the wire is given as rho L by A, or resistance is proportional to the length of the wire, because we are going to use all this in the problem. Okay, the heat produced raises the temperature of the wire. So according to calorimetry, the heat produced is given as ms delta T, where m is the mass of the substance, S is the specific heat of the substance, S is the specific heat of the substance, and delta T is the increase in temperature. Now we should relate the heat produced to this. So we can now write this as V squared by R equal to ms delta T. In the first case, V1 equal to 3E, because we are taking 3 identical cells and connecting them in series. The voltage potential given is 3 times that. Okay, and let us take R as R1 when the length is L. In the second case, we are connecting N cells. So V2 is Ne. What is R2? R2 proportional to the length. So it becomes 2R, because length is now doubled. Length of the wire is now doubled. Therefore, the resistance becomes 2 times. What about the mass? Mass is also volume into density. When you are doubling the length, the mass also gets doubled. So M1 is M and M2 is 2M. So what all changes now? First case we are connecting 3 cells, so 3E. Second case we are connecting N cells, so Ne. First case the resistance is R proportional to L. We are doubling the length, so resistance becomes 2R, mass also becomes 2M. So now let us write 3E whole square by R 1 equal to M1S delta T, Ne whole square by R2 equal to M2S delta T. We can take this as 1 and 2. Dividing 1 by 2, we get 9 by n square. 9 by n square into 2 by 1. This is for R2 by R1 is equal to 1 by 2. So n square equal to 36. N is equal to 6. So the number of cells connected is equal to 6. Answer 2.